Good afternoon, everybody, and welcome to our next session, which will be all about cybersecurity. My name is Lea, and I will be your moderator for the next roundabout 1.5 hours. So since cybersecurity is one of the most important topics when it comes to building trustworthy AI systems, I am thrilled that we have 4 amazing speakers today to talk about their perspectives on cybersecurity. And the first panelist today is Daniele Molteni. He leads the web application firewall product team at Cloudflare, where he launched a number of products in the web security and IPA protection space. Before joining Cloudflare, he worked at Nokia and in the oil and gas sector. And in addition to that, he was an investor at the venture capital fund focused on AI systems. He holds a PhD in signal processing and an MBA from the London Business School. Daniele, it's a pleasure to have you. The floor is yours.
Thank you. Thank you very much for the introduction. Good afternoon, everybody. So let me familiarize with you. Okay, this is the clicker. So I'm a product manager at Cloudflare. For who doesn't know Cloudflare, we are a cybersecurity and performance company. We basically provide solutions and systems to speed up the internet and make it secure. So anyone who has an application, has a website, can use Cloudflare to protect their traffic and their systems. Today, we're going to talk about how we're going to use AI to protect basically internet traffic, to block hackers from hacking into those applications. The title sounds a little bit cryptic, 0 day before 0 day. So if you don't know what a 0 day is, don't worry, we're going to talk about that in a second. Great. So a bit of an outline of what we're going to cover over the next 80 minutes. So first of all, I'm going to introduce the idea, what's a web application firewall and what's a 0 day. And then after that, we're going to go into a little bit more details about what's the big problem with the WAF, which is the time it takes to mitigate attacks. And then the third section is more about the AI component. So how did we use AI to identify those attacks early on? And finally, we will close with some thoughts about how we see this going forward and in the future. Okay, what's a web application firewall? So when we talk about web application, we refer to anything that runs on the internet. Like if you have to pay your taxes, you usually go to a website. That's a web application. Mobile application also, they rely on a server running a service. Think about your online banking system. When you check your account balance, you usually send what we call a request. It's HTTP traffic that goes through the internet and reach your banking system, banking server, and then with the response, you get all your information. The WAF, or web application firewall, sits in the middle. A firewall is something that is a gate, basically, that blocks the bad stuff and lets through the good stuff, right? So it let in the requests that are performed by legitimate users, like you checking your bank account, but the WAF blocks attackers trying to exploit vulnerabilities in the web application. Okay, one more slide for context. What's a 0 day? So we refer to 0 day as a software vulnerability. So if you run a website, an application, you're probably going to rely on a bunch of software on a stack that is not all software you have written, you have full control, right? So you're probably going to run some databases, you're going to run the web server itself. All these software, they do have bugs, holes, and vulnerabilities. And we call 0 day the moment where one of these new vulnerability is made public. The WAF is basically a rule-based system that blocks these attacks based on these vulnerabilities. So the WAF has a bunch of rules that block those attacks. Okay, so what's the problem with WAF? So the WAF has been around for a while now, for more than a decade. And I'm going to walk you through what has been the process of protecting traffic until today and what's wrong with that. So let's say a 0 day get released. So one of the biggest 0 day of vulnerability that was made public was what we call Log4j, which was software that basically an open source software which was banned by the Apache Foundation, which allows to manage logs on infrastructure. It was extremely widespread because it was open source. And so when this was released, it was a big deal, right? Because this was affecting a lot of the internet. So you can imagine a release as someone like publicly on the internet say, we actually have this problem, we need to fix it. And from the moment when that is made public, a race starts. And like with any good Hollywood movie, you have the good guys and the bad guys. So the bad guys are like hackers or attackers. And what they try to do, by the moment they know that exists, is just to try to break into their targets and their, maybe they have a company or a government website they want to take down. And so they just try immediately to break that and to exploit that for their gain, whatever that is. The good guys are what we call the security analysts. They're probably not as fashionable as great actors, but they start to work from the moment this is made public, they start to try to find a way to block those type of attacks. And they do that by creating rules in the WAF. The problem is that it takes time. So for this specific vulnerability, it took us 19 hours to get a rule that was blocking the attacks. Other times was like 3-4 hours, but still it takes time, takes hours. And in those hours, attackers can just do whatever they want. So the question here, can we bring this time to mitigation to zero? Can we make a WAF, a firewall that automatically blocks these attacks before they're even made public, made known? Just to give you a sense of what a security analyst, what's the output of their work, this is one of the signature, we call it like a signature. So it's the rule that runs on every request for Log4j. So it's basically a regex, or it's basically you're looking for string, a specific sequence of characters in the request. They're basically, just a series of characters. And this takes time to develop and to make it so that it's very, there's very low false positives and it's very high false positives. So when there is a match, you know there was an attack and you want to block everything, shut it down. So you might ask, okay, what's so difficult to get to zero time to mitigate? So the problem is that those signatures needs to be extremely, extremely tuned to avoid the false positive side. So you don't want to block you sending a request to your bank and say, oh, I think it's an attack. You're like, no, I just want to see my bank account. So you want that not to happen, but you also want to, when there is an attack, you want to catch it, right? You don't want to let it through. And that's a problem. That requires time. And that so far has relied on humans, those security analysts. We have incredibly smart people at Cloudflare, like in other company, I'm sure. But the problem is that human takes time, right? They need to think about what they need to write. They need to test it on traffic. And sometimes those vulnerabilities get released, get made public in the worst possible time. You know, on a weekend, maybe Log4j was doing Christmas. So it's when perhaps you're not the most ready to act. So, of course, we are here in an AI conference. So we used AI in the last years to come up with a solution that brings this time to mitigation to zero. Of course, this is not generative AI. You're talking about more like a classification type of tool. So it's it's a machine that's been designed to accomplish this task with extremely high precision. Okay, so let's go into the nitty-gritty. I'm going to show you 5 steps, which is how we build this product and how you can interact as a customer, basically, or as a user. So the first step, like in any AI, ML problem, the big problem, the big issue you have to start with is the training set, right? Your model is as good as your training data set. And so can we build this? Do we have the training data set? So luckily for us, we have a very, very broad or wide data set. The reason is because we have been around for 11 years. We had 11 years worth of rules, those signature-based rules I talked about, the one written by the security analyst. So those rules generate a constant stream of true positive with high confidence, right? And everything else is just true negative. And the other factor is that we process about 70 million HTTP requests per second. So we have a huge stream of data, and we can rely on those requests that are flagged as malicious. There are different estimates, but Cloudflare, someone says that Cloudflare processes about 20% of the internet traffic. So chances are that if you are visiting a website, very often, more often than not, you're actually going through our system. One of the challenges we actually had to solve, rather than create the training data set, is to clean it up. So the big problem we have is that those requests, they usually contain PII. So your personal identifiable information, your sensitive data from customers. Again, with the example of the bank, that might be your bank account, right? Your bank details. So we needed to to remove those PII to be able to use it in the model. Step number 2 is, can we enhance this training data set to make the performance of our model even better? So this is an example here. This is like true. There is no attack in this example. So the performance here refer to the classification performance. So how likely is that given this signal, we flag it as malicious or not? And without augmentation is around 60% or even less. After the augmentation step, we have a staggering difference, and the performance of the classificator is much higher. When we say augmentation, what we are saying, we're just making, we just throw a bunch of keywords, we add some fuzzing characters, we make it like so that the model is a bit more robust. So if it sees a variation of what we feed into, like in the wild, then is kind of like it can cope with that, right? It can understand that. So this is a very important step that we've seen enhancing a lot the performance. The other challenge is probably very specific to Cloudflare. So because we're talking about HTTP traffic, internet traffic, the users are very sensitive to delays and latency, right? So if you're running, for example, an e-commerce shop, you know that, right? Any delay in the time you return the page, people won't buy and just walk away. So we need to be extremely performant. So any classic, let's say, library that wasn't enough for us, so we had to go to use something very, very performant, very, very light, that we could run it at basically for every request. So one of the questions I get asked time and time again is like, okay, great, the ML model, how much time does it add to my request on the path to the server? So P90, so 90% of HTTP requests, we process the inference in less than 2 milliseconds. So it's not noticeable. It's not noticeable if you are a human trying to interact with an application. Step number 4 is deploying this model at scale and make it run on the internet. As I said, we are a big company. We have like 300 data centers spread around the world, and we had to basically create a pipeline to push this model to what we call the edge, so these data centers. So the first step, of course, we select only the HTTP request. The second step is normalization. There's a big part of it because out there is the internet traffic is very noisy, so we need to remove that noise. The third step is we extract the features we're interested in. This is where a lot of the secret sauce lies. So here we basically take what's a string, a series of characters, and we transform it in a series of features we can understand, we can use in the inference model. And then, of course, you run the inference model, and the output of the model is a score that tells you the likelihood that there is an attack in the request. So we basically output a score. Is like, is this a request? Yes. Is it an attack? Yes, which is a score of 1. And if it's clean, is a score of 99, and anything in between. This is the output of the inference of the model in a pretty form. This is how the users of this product interacts with the product. So you see, each bar is the total volume of requests you have seen on a specific time period. This is for our blog, for Cloudflare blog. So we get a lot of traffic, a lot of visits. And you see it's color-coded based on the scores, on the output of the model. The green one is like, this is good traffic, there are no attacks. You see on the right, there are some red bars. This is where we identified an attack, where the score is very low, and we are sure that it's something you need to block. So you can quickly, by glancing at the chart, you can quickly see where the attack happened. The way the customers interact with the model and the output and they use it is by creating a rule. So as I mentioned, the firewall is a rule-based system. So customers can write some logic in the WAF to say, if the score of this request is less than, let's say, 10, then block this request because it's malicious. So the way the interaction works is extremely straightforward. Okay, so how does it work? Does this work? And what's the time to mitigate? So we actually can say that we brought time to mitigation to 0. Because we went back to certain 0 days, certain attacks that have been released, made available in recent past. And for those attacks, so those are for CV here stands for 0 day or for attack, for vulnerability. Those 4 vulnerabilities, we didn't have a signature for them, right? So analysts didn't know there was a hole in in some software, and so didn't develop any signature for that. So we could look back, but we could look back at the model, what the model was thinking about this. Did the model, the inference, thought there was an attack or not? And the answer for all of them was yes. So even if we didn't see this attack before and someone was using this system, would have been protected from the first instance of this type of attack. So this is basically a success. So the system works. Of course, there are limitations. And if the attack, basically this works very well if the attack are a variation or very similar to things we have seen already in the past. So if anything like SQLI, XSS, remote code execution, this works extremely well. For other attack vectors, this can be a bit more challenging, and maybe it's not ready yet. So there are of course some limitations. But if for any variation, any attack which is similar to this, it works great. Great. I'll spend the last minutes talking about more how we are going to use this to improve it even further, right? So the great thing here is that we are still running the old WAF, which is signature-based, right? The one that the humans write rules for. And so we can compare what the ML model says and what those rules says. So the bar on the left, these are all the requests that have been flagged as malicious by the model. The smaller bar on the right, that's what the signature-based WAF flagged as malicious. So there is a difference here, right? So there are a bunch of requests that the model thinks are bad, but the human system thinks they are perfectly okay. They didn't match. So now our security analysts, they are focusing on this difference, right? They are taking this request and say, let me check why the model thinks that this is bad. And they can use that information to create even better rules, right? And why is this important? This is extremely important because we can create a feedback loop. As you remember, the rules, they were the rules that the one creating the training set. So if we improve those rules, we improve also the training set for the ML model. And so you create a reinforcing loop. So you eventually will end up with a better model, with a better ML model that will cover more of the attacks. Great. So just to summarize, I guess the question is, can we use AI ML to improve application security for internet traffic? And the answer is yes, definitely. That works very well. We also managed to bring time to mitigate to 0, which was a very hard problem to do. But we still recommend to use both systems. So this is an example where human made system and the human experience, if you want, and the ML can work together to really provide the best results. And with that, well, thank you. That's all for me.